Okay. So what I'm going to do is basically one of the questions that I told you about. Need to make sure. So your test first, I guess, before I get there. Your test is over chapter 4. It's over linear regression, basically. And there's a couple of really important things about linear regression, which you can see up on your screen right now. Okay, so this entire kind of chapter is dedicated to finding this line of least squares. Okay, and there's a couple of things that we need to know how to do. We need to be able to find our sample correlation coefficient R, which basically tells us how close our scatter diagram is to a perfect line, right? So if it's 1, and I have this written over here, if it's 1, all of our scatter points are exactly on a line and it's a positive slope. If R is 0, our points are just kind of scattered all over the place. If R is -1, then it's also a perfect line, but it's going in a negative direction, right? So if we just kind of draw that, if R equals 1, all of our points lie on a line. If R equals 0, they're kind of all over the place. So there's no linear correlation. And then if it's R equals -1, it's got a negative slope, and they're all on that line. Okay, so that's kind of telling us how close our data points are to a line. Then we have to find the line of least squares. So from Algebra 1 and Algebra 2 and a little bit of geometry, we know that the equation of a line is y equals mx plus b. And we're basically using that. We're just rearranging it and giving us a couple of different letters to talk about, right? So line of least squares, we're going to call y hat. So y with a hat on top. A is going to be our y-intercept. B is our slope. And then x, as always, is variable. Okay, so to find b, we find we take the number of data points we have. Probably won't be able to read that, but that's number of points times the sum of the product of x, y, right? So we're taking each of our data points, we're multiplying them together, and then we are adding each of those pairs, okay? Minus the sum of x, so we're summing up all of our x values, times the sum of y, so we're summing up all of our y values. That's the numerator. And then on the denominator, again, we have n times the sum of x squared minus the sum of x, and then squaring that. Okay, our y-intercept, we're just going to set a equal to our y bar, which is the average of the y's, minus b, our slope, times x bar, the average of the x's. And then we need to be able to interpret this line. So how good is this line? That's what r squared tells us. R squared is the percent of variation explained. So if r squared is like 0.76, that means that 76% of the variation is explained for that scatter diagram. That also means that 0.24, so 24% unexplained, and 76% explained. Okay, and that's kind of the main point of this entire chapter, and that's what I'm going to be testing you on. Okay, so in order to kind of go through this, I'm going to go through step by step about what I'm expecting. All right, so this is like all the stuff we need to know if you're looking for things to like quote unquote memorize. We need to know how to find R, and we need to know how to find y hat, which is pretty much all this stuff. Everything else should kind of come with it. Okay, so I guess before I go down, we need to be able to also find sum of x squared, sum of y, sum of y squared, the sum of those products, and I think that's about it. And then X bar, Y bar. So all of that we should be able to do automatically. And then we're just plugging those numbers into the equation for R and the equation of B. Okay, so I'm going to scroll down, and I have a question here that is number 11 on the review exercises for chapter 4, right? So this is okay, and I'm going to make this a little bit bigger. Okay, so this question says, modern medical practice tells us not to encourage babies to become too fat. Is there a positive correlation between the weight X of a 1-year-old baby and the weight Y of the mature adult 30 years old? A random sample of medical files produced the following information for 14 females, right? So X, that's going to be the weight of the 1-year-old. And then Y is going to be the weight of that person at 30. Okay, and we get these data points. Okay, and what I'm going to be asking you are the following. So first, draw a scatter diagram, and based off of that, what is going to be the predicted R that you would think is going to happen? Okay, so without doing any calculation, I'm just asking you, based off your scatter diagram, what do you think R is going to be? If it's a positive slope, it should be positive. If it's a negative slope, it should be negative. If it's all relatively on a straight line, it should be near 1. If it's like all really scattered, it should be more closer to 0, and so on and so forth, right? So that's part A. Part B says to find the average of the X, the average of the Y, our slope for our line of best fit, and the equation for the least squares line, which is like the line of best fit. Okay, and that's Y hat. I wrote that kind of bad though. And then plot that on the scatter diagram. Okay, so we've drawn a scatter diagram, we've thought about what our R value is, and then we found the line of least squares for that scatter diagram and then plotted that. And then we need to find R and R squared, and then determine what percentage of variation is explained. So that has to do with R squared, which I talked about above. And then we're going to make a prediction based off of some X value that I give you, right? Mostly we'll be interpolating, so I'm going to give you something in between the X values that have been given. It's usually not great to extrapolate, but that's a problem for later. Okay, so that's the problem. I'm probably going to give you one of these, and then that's the test. Okay, so let's just get started. And I might mute myself a little bit here just to not have the mic on the entire time. Okay. Let's see. Okay, so X values go from our minimum, which is 15, all the way up to, looks like 26. So that's 9, right? So we can do this. so that's 9 wide, and then our Y values go from 115 to like 150. So that should be about right. So I'm going to label these. So X goes from 15. And then our Y values go from, looks like 120 to 140. And then we're just going to plot things. So I'm going to mute myself and I'm going to do this. Okay, so here's our scatter diagram. I mixed up a couple. I didn't go down far enough. All these should be pushed up like 10 units, but that's okay. So here's our scatter diagram, what I would expect this line to look like. And I'll do this in red so we can see it, or green. It's going to be something kind of along the lines of this, right? So I don't know that yet, but that's kind of what I'm guessing. Okay, and if we were to guess, so all this in white will be part A. If we were to guess what R square or R would be in this case, I would guess R is probably not super close to 1. I would guess it's about 0.5. It's pretty loosely spread around that line. So I'm going to make a prediction and say 0.5. Okay, and there's going to be a lot of different answers for that. I would explain it. Okay, so data points are loosely spread around that line. So that's part A. Part B says to find x bar, y bar, and b, and then the equation for the line of best fit. Okay, so I'm going to erase this. This is just kind of a guess that that green line was. And I'm going to start finding that x bar, y bar. Okay, so we'll do this in red, and I'm going to scoot some things around. Okay, so part B, we need to start finding x bar. X bar is the average of the x's, so we're going to have to find the sum of x over n. So I need to get a calculator. So all this is the sum of all of this stuff up here. So this would be 21 plus 25 and everything in between all the way up until 19. And then there are 14 of those. So all this would be over 14. So our sum is 300. And if we divide that by 14, we get 21.43. And I'm also going to label the sum of x because we're going to need that for later. We also need to find y bar, which is the same thing but for the y values. So we sum up all those y values, we get 1775. We divide that by 14. And we should get $126.79. So I'm also going to label the sum of y because we're going to need that later. And we found x bar, we found y bar, now we need to find b. And in order to find b, there's a couple other things we have to find. So we have to find the sum of x squared. Oops. And the sum of y squared. And the sum of xy. Okay, so the sum of x squared, I'll do that. Well, no, I'll do this somewhere else. Sum of x squared, this would be 21 squared plus 25 squared plus all the other data points squared all the way up until 19 squared. And if we do this, 21 squared plus 25 squared plus 23 squared plus 24 squared plus 20 squared plus 15 squared. And we get 6572. We need to do the same thing for the y values. So kind of running out of room. Hold on a second. So this would be like 125 squared plus 125 squared plus 120 squared all the way up until 115 squared. Then we gotta type that into a calculator. So 125 squared plus 125 squared plus 120 squared plus 125 squared plus 130 squared plus 120 squared plus 145 squared plus 130 squared plus 130 squared plus 130 squared plus 130 squared plus 140 squared plus 110 squared and plus 115 squared. And when we do that, we get 226,125. And then we need to find the sum of their products. So I'm going to do this down here so I can still see that data. So this would look like 21 times 125 plus 25 times 125 plus 23 times 120 and so on. And when we do that, we get, oh, I typed something in wrong. Okay, hold on a second. And when we do that, sorry, this is taking a while to do on my calculator. So when we do that, we get 38, 220. And then we have all the values that we need. Okay, so I'm gonna copy these down. Okay, so we're in part B. We found the average of the y, we found the average of the x, and then what we're gonna do is we're trying to find b. Okay, and we know that b from up above is equal to all of this stuff. That square should be on the outside. And now all we have to do is just plug in. Okay, so n, that's going to be 14. We found the sum of xy, that is 3822. We're going to subtract the sum of x times the sum of y. I'll put these around for parentheses. There we go. All divided by n, which is 14, times the sum of x squared, which is 6572, minus the sum of x and then squared, which is 300 squared. Okay, so we have now our equation. Now we just got to type this into a calculator and get our slope. Okay, so 14, and if I'm going to do this kind of step by step so we can check ourselves as we do this. So 14 times 3822, that's 53,508. minus 300 times 1775. That's 532,000. 500. All over 14 times 6572. Minus 300 squared, which is 90,000. Then 53,508 minus 532,500. It's negative 478,992, all divided by 9208 minus 90,000, which is 2008. So I think I did something a little bit wrong here. Hold on a second. Okay, I did something wrong, so I gotta correct this, so hold on a second. Got it. Okay. I just wrote one thing wrong. So over here, there should be a 0. Right. This was our sum of xy. I just wrote it in wrong. So now if we do this, it should work out. So 14 times 38, 220, minus minus 300 times 1775. All over 14 times 6572. Minus 90,000. Now if we do this, it should work out. So 53, 5080 minus 532, 500. That's 2580. All over 92,008 minus 90,000. And if we do this, we get 1.284. So this is going to be our slope of our line of best fit. Okay. So then now we have to find A. A is equal to the average of the y's minus B times the average of the x's. So the average of the y's is 126.79. Our slope was 1.284 times the average of the x's, which was 21.43. So if we do this, we get 99.27. So we have A and we have B, so then our equation of our line of best fit is going to be y hat is equal to 99.27 plus B 1.28 times x. And then this is our equation that we're looking for. Okay, so that's all of part B. So sorry I screwed up a couple times, but I just wrote a couple numbers in wrong, which is why doing this part right is so important. Because if we can do this part right and we can verify all that stuff and then plug it into our equation for B and A, then we're going to get our correct line of best fit. Okay. So that's all part B. And then part C says to find R and R squared, and then what percentage of variation is explained. All right. So I'm going to put this stuff a little bit over. So C says to find R. And R looks a little bit like B. It's the same top part. So this is going to be N times the sum of xy minus the sum of x times the sum of y, all over the square root of n times x squared minus the sum of x and then squared, and then times the similar looking thing for y. Okay, so n times the sum of y squared minus the sum of y and then squared. And then all we're doing is plugging this stuff in. Okay, so 14 times the sum of x, y, so 38,220 minus the sum of x times the sum of y, which is just 300 times 1775. On the bottom, we get the square root of 14 times the sum of x squared, which is 6572, minus the sum of x and then squared, which is 300 squared, and all that times the square root, so 14 times the sum of y squared, so 226125, minus the sum of y and then squared. So now we just got to do this. So up top, we're going to get the same thing as we did on the right. Right? This is the same numerator, so we're just going to use that. That turns out to be 2580. (14 times 6572) minus 300 squared again, that ends up being the same as up here, and then times a little bit different, so 14 times 226 125 minus 1775 squared. So then we get 2580 over the square root of 200 or 2008 times the square root of 3165 750 minus 3150 625. So this is that number, and then 2580 divided by that is 0.47. Okay, so that's R, which is really close to our prediction that we made up top. So from our scatter diagram, everything was kind of like loosely kind of packed around the line that we kind of determined by ourselves. And we came up with this prediction, okay, which is pretty close to our actual R value when we actually like mathematically find it. Okay, so what this tells us is that the data points from our scatter diagram are pretty close to a line. They're at least in a positive sloping direction, but they're not quite exactly on it. Okay, so that's what that says. And then R squared would tell us a little bit more. So we take R, we take that 0.47, we square it, and when we do that, we get 0.2209. And what this says is, this says that 22.1%, so 22.09% of all the variation of that scatter diagram up above is explained variation, right? It has to do specifically with changing the x values. And then 100 minus that, or 1 minus that, is 77.91%, is not explained. So this has to do with like lurking variables and all that stuff, right? So this is random chance. There's more than just weight of baby and weight of 30-year-old adult. Okay, so that's part C. The one thing we kind of forgot to do is actually to plot this line. So let's do that really quick. 99.27, that's our y-intercept. That would be, so this would be like 110. So it'd be like down here, right? So this is kind of our imaginary y-intercept. And then we're going to go up 1 over like a fifth or a third. It's going to go over, up 1, and then over kind of in the middle. So we're going to get a line that kind of looks like this. .284. Okay, so that's A, B, and C, and then D said to make a prediction. When x equals 22.5. So when x equals 22.5, if we just plug that into y hat, we get y hat is equal to 99.27 plus 1.284 times x, which in this case is 22.5. We just plug that into our calculators, and we get an answer. So 99.27 plus 1.284 times 22.5, and we get 128.16. Okay, so that's our prediction, and that entire question is like the test. All right, but before I kind of get to that last part, a couple of things to note. One, this prediction isn't great because our r squared and r values are not closer to 1. So this kind of tells us a little bit of the story, but it doesn't explain everything. And the reason being is because our scatter diagram, right? If we drew that line of best fit, our points are going to be scattered all the way around that line. Right, so our R value isn't close to 1. And most of our data is unexplained. Right, so all that comes from this. We get y hat in part B. We find our kind of closeness to that line in part C, and then we explain all that in part D for our prediction. Okay, so that whole thing is one entire question. All right, and that's all I'm going to be asking. Right, so we're going to take data, we're going to make a scatter plot, we're going to make a prediction, then we're going to find the line of best fit, which is all this stuff in red. We're going to find our kind of explained and unexplained parts, which is part C, so finding R and R squared. And then we're going to make a prediction and explain how good that prediction is actually going to be. Okay, so that's the entirety of that. Hopefully, like I get that there's not a whole lot of people watching right now, but that's fine. If you have questions about this, please let me know, and I'll do my best to answer. Okay, so I'm going to pause this, and I will see you guys in a couple of days. All right.